Hello students, today we're going to start with a warm-up. We're going to also write formulas from explicit to recursive and also vice versa. So we're going to be, if we're given one, then we're going to find the other. And then the assignment is 9.3. Today students will be able to write recursive and explicit formulas from sequences. We did that the day before yesterday and also yesterday. And today we're also going to convert from one to the other. Okay, so we're going to start with a warm-up. If you want, you can just pause it right now and take a couple of minutes to complete it. So it's find the explicit formula. And then you have 2 questions. So for the first one, we can see that we are adding plus 1, right? We're adding 1 each time. And so for the explicit formula, remember that we need this part and also this. So it's going to be f of n equals the initial point, which is 1, plus 1, and then always when we are adding, when the sequence is arithmetic, then we just put times n minus 1. In the next one, to go from 10 to 9 is minus 1, minus 1, minus 1. Again, what we need is the initial point and the pattern that it's taking place. It's going to be f of n equals the initial point, which is 10, the pattern, which is minus 1, and then multiply times n minus 1. For the next one, what are we doing in here? Some people said, oh, we're adding 0, plus 0, plus 0, plus 0. That could be a possibility. So if we're adding 0, the function would be the initial point plus 0 times n minus 1. However, other people say, oh, I thought we were multiplying by 1, multiplying by 1, multiplying by 1. So they cite us not as an arithmetic sequence, but rather as a geometric sequence. And so in that case, if it's a geometric, it means multiplication. So it's going to be the initial point, which is 1, times 1. And in that case, it will be to the n minus 1. That's a tiny number, okay? N minus 1, not as a multiplication of, but as a power, n minus 1. Okay, that's for geometric, for multiplication. In here, we're multiplying times 0, multiplying times 0, multiplying times 0. So my function is going to be f of n is equal to my initial point, which is 8, and then times 0. Again, whenever we're multiplying, whenever it's a geometric sequence, we have the power of n minus 1. And here you can use your own words, but when do we use recursive formulas and when do we use explicit formulas? If you recall, recursive is only when we're finding, when the input is a small value, meaning that you're finding for the next day or for the next 2 days, because it always comes back to the previous day or the previous year or the previous month, okay? We look at the value of the previous input. For the explicit formula is when the input is a big number, okay? What if you are saving money and you want to find how much money you have in 1,000 days, okay? So again, explicit, when you want to find a specific big number as the input, and recursive is depending on the previous, so you don't want to have to find. And we'll come back to this, or you can view the videos from before to see the difference, okay? So let's start with a list of numbers. If we have, let's say, 3, 6, 12, 24, 48, etc. First of all, what kind of sequence is this? What are we doing in here? Are we adding 3 every time? Plus 3 is 6. Plus 3 is not 12, so that means that I'm possibly multiplying by 2 times 2. 6 times 2 is 12. 12 times 2 is 24. So since I'm multiplying, that means that this is a geometric sequence, okay? And what I need to write my formula is my initial point and also my base, right? So I'm gonna write the explicit formula first. Explicit formula. And I need f of n is equals to my initial point, which is 3. I'm multiplying by 2. And remember that when I'm multiplying, then the n minus 1 is going to be n minus 1 right there, like an exponent. Okay, that's my explicit formula. How would I write my recursive formula? Okay, the recursive formula, I have 2 pieces to it. I have f of 1, and I also have f of n. My f of 1 is always my initial point. In this case, 3. Okay, that's always going to be the first value. And f of n is going to be, look at the previous value. And how do you represent that? As f of n minus 1, okay? Why? Because let's say that this is the second value, it would be 2 minus 1, so 2 minus 1 is 1, so look at f of 1, that's what it means. And what am I doing to it? I'm multiplying times 2, okay? So that's how my recursive formula would look. You have f of 1, which is my initial point, and then something that brings me back to that one. And then it would always bring me to the previous one. So that's how you write the explicit formula and the recursive formula from a list. Let's do another example. Let's see, we have 7, 12, 17, 22, 27, etc., etc. And you can probably already see the pattern. What are we doing? Is it arithmetic or geometric? As you can see, we're adding 5 each time. We're adding 5 each time. When we're adding or subtracting, that's an arithmetic sequence. Okay? And if I want to write the explicit formula, then I'm gonna have only one formula, that's it, one part to it. So it's gonna be my initial point. Remember, I always go back to these 2 parts. My initial point, which is 7, plus 5, and then since it's arithmetic, I'm gonna put it as a parenthesis in here instead of exponent, and minus 1. Okay, and that's it, that's the formula, that's the explicit formula. If I want to write it as a recursive formula, you have 2 parts to it. The first value, and then how to get to the next value. Okay, so in here, the first value is my initial point, which is 7. And how to find the next value is going to find the next value, you go back to the first one. To find the third value, you go to the second one. To find the fourth value, you go to the third one, and so on. And what am I doing to that first value? I'm adding 5, so plus 5 in here. Okay, so that would be my recursive formula. One thing that I want to mention before I move on to a separate piece of paper, if we go back to the first one, I just wanted to say that there is another way to write this. Some books or some people will have this function, and it's exactly the same thing, okay? Both are correct. They put the coefficient, the 2 as a coefficient. So 2 multiplied by this, or this function multiplied by 2 is the same thing. So another way that it will look like is like this, okay? Both are correct. F of n equals f of n minus 1 times 2, or f of n equals twice f of n minus 1. Same thing. Okay, let's do some more examples. Okay, I want you to tell me what kind of formula is this? If it has 2 pieces to it, is it recursive or is it explicit? We know that if it has 2 pieces, if it gives me one piece as f of 1, which is the initial point, and then the function, then that's the recursive formula, okay? Now I want you to change this recursive formula to explicit. How do we do that? I'm going to start doing using different colors so that we see where each piece fits. So I'm going to even draw little figures. I'm going to put a heart in here. Okay. My explicit always has f of n, right, equals my initial point, which is in this case my f of 1, goes right here. And since I'm adding in here, it looks like it's going to be arithmetic. So I'm going to add 2, and then I'm going to open my parentheses and minus 1. Okay, remember that if it's adding or subtracting, we multiply by n minus 1. If it was a multiplication, then n minus 1 as a power. Okay, so if you notice, this is the same as this, except that it gets rid of the f, because we don't go back to the previous f of whatever that number becomes. Okay, we don't go back, so that's why we don't have the f in there. But these two, these two comes from here. So those are the 2 pieces of information. This comes from here, and this comes from here. Let's do another one. Number 4. If I have f of n is equals to 5 plus 2 times n minus 1, I'm almost running out of time, but this is only one piece, so what kind of equation is it? Well, it doesn't have 2 pieces, so it's not recursive, so it means that it's explicit. And I'm going to change it now to recursive. And I said that for recursive, we need 2 pieces of information. This is always the initial point, which is right here. This is my initial point, so that's what I'm going to put in here, right? And for the f of n, I'm going to write, remember that it's always go to the previous one. So the function of n minus 1, meaning f, go to the last one. And what am I doing? I'm adding 2. Okay, so that will be the recursive formula. Okay. Okay, the bell rang, but I'm just gonna share that this comes from this number, and so that's the two pieces. Let's see if I can do one more before I open the door. So if you hear noises, it's probably because my students are coming in or want to come in. Okay, what kind of formula is this? Well, it doesn't have two pieces, so that means that it's explicit. And how do I change it to recursive? Again, recursive has two pieces to it. And so my initial point is still the same, right? Oops, it's supposed to be a heart. So that's the same. And here is going to be always look at the previous in the list, okay? And what am I doing to that initial point? Well, I'm multiplying by -2. Some people put parentheses, some people don't, but that's how it would look. Now, something that I want you to notice is that explicit, see, n-1 is an exponent, okay? Again, the initial point goes with f of 1, and whatever you're doing to the initial point, that's what you're doing to the previous one in the recursive formula. So that's it. Remember that the homework is 9.3 and hope you get it.